Hey guys, John Statistic Alicia here again with the Sharp app, and this is our next lesson in the Sharp Academy where we are teaching you guys how to become sharper, smarter, more profitable bettors. And that's our real whole goal here with the Sharp app and the Sharp Academy. So welcome again to this lesson. And we're going to be talking about linear equations, linear modeling, linear regression modeling more specifically. So what does linear mean? Well, if you go back to high school or college and think about some of your math classes, you remember doing slopes of lines. Linear line is just going to be a straight line. That is it. Now, if you remember what a graph looks like in college with a straight line, you're going to have a y-axis. Your y-axis is that vertical axis, usually shown on the far left-hand side. I'm going to show you some graphs in a minute, but the y-axis moves vertically. That x-axis moves on the horizontal. A perfectly linear line is going to move in step. Whatever the units are for x will move in step with what the units are for y. Now, that is not always one for one. We may be moving for every 1 unit of x, we may be moving 2 units of y or 3 units of y or a half a unit of y, whatever that may be. That's going to give us a perfect line if we are moving in step. What that also does is give us a very accurate prediction. If we change the x variable, we will know exactly what y is going to be. So if we know something moves 2 to 1, and that is 2 times for every 1x. So if we move 1x, we're at 2 on the y. If we move 2 x's, we're at 4 on the y. We can then pick any number we want along that x-axis and know that if we multiply it by 2, that's going to be what we get on the y-axis. Hopefully that's pretty simple to understand, and you might be able to start seeing where we're going to use this as some sort of a predictive model in sports betting. But first, what I've done is I put together a hypothetical business. Let's call it an ice cream shop that is very much dependent on what the temperature is outside for what the revenues they're going to generate. So we know in the wintertime, generally ice cream parlors are not going to make nearly as much money as they will in the dead of the summer. This would be one variable that if you owned an ice cream shop, you'd want to know. If it's 40 degrees outside, what can I kind of expect my revenues to be? And let's just see if there is a correlation. You kind of suspect there might be a correlation, but you'll do a linear regression model and figure out exactly if there's a correlation, how much of a correlation there is, and is it predictable. So let's head over to the spreadsheet. I'm going to show you an example of that, and then we'll start getting into some sports stuff. All right, guys, here's our spreadsheet for our hypothetical ice cream parlor shop. And all I've done is put in revenues that are lower for when the temperature is lower, and I've added revenue that is higher for higher temperature days. And I've done this for every single day of the year. I did this randomly, but I accounted for higher revenues for when the temperature was higher, and of course changed the range of what the temperature could be based on the month. So we're just assuming I was back in New York here, and this is kind of typical New York weather. As we get into the warmer months, we've got $459 on July the 10th, 2020, because it was 91 degrees. The next day was 80 degrees, and we made $283 in revenue, so on and so forth. We had a few days here that were a little chilly in July, and we just didn't make as much. We made $80 and $79 on a 66 and 65 degree day. So if I was an owner of a shop like this would be a model I would not mind running, because it would help me figure out just how much of my revenue is being generated by just the temperature. What are the other factors? These problems are always going to be multivariable. So the more variables that you put into your model that are pertinent to that model and actually do make a change, in this case in revenues, the more accurate your model is going to be. But let's start here with temperature and just see just how much of a factor temperature is to how much we're making in revenues. Now, how we would do that is, after I've got this all set up, you go to your data tab, and then the upper right hand corner, data analysis. If you do not have data analysis in your data tab, it's very easy to add on. You just need to go to file options, your file options tab, and then your add-ons, and add data analysis. There's plenty of help in Google in adding these tools, but you see your data analysis tool needs to be enabled. So we've got the data analysis tool. It opens up, and we would scroll down to where it says regression, and this is what we want, the regression model. Now, our input. The Y range. Y is the dependent variable. It's what we're solving for. Because again, what's our problem? Our problem is we don't know how much revenue we're going to make depending on what the temperature is. And that's what we want to solve for. So here's all of the revenue in column B. That's going to be my Y range. Column X, that's my independent variable. I have no control over X. That is what we are trying to figure out. When X changes, what's the effect on Y? So it's an independent variable. And there's only one variable here for the problem. That is temperature. So we're going to put our C1 through C367. That's pretty much everything here in column C. If you'll notice, I added the first row here, revenue and temperature, to our columns because I've got labels clicked. So I'm going to want to see those labels when I run this. I want to see what each one of those are, so it makes it a lot easier for us to follow exactly what we're looking at. You'll see that when I run it, why we want that. Okay, constant is 0. We're going to leave that blank. We're not going to check that. Confidence level, we're not going to check. The only other thing you need to look at is output options. This is going to tell Excel where you want to see this data. I actually ran this earlier and I put it in E2 exactly with all these statistics, and you'd be able to analyze your data. Now, the key numbers for us that we're really worried about here for this purpose is R squared. We want to see R squared, and adjusted R squared is always going to be slightly lower than the R squared. What you just really want to focus on right now is R squared. That number is going to tell you how correlated the data is to each other. Is temperature correlated at all to revenue? And this 57 is it's a pretty high number of correlation. There is a correlation there, and we could actually see that on the chart that also came out here, the graph. And you could see the line does go up. It continues to go up, revenues, and on the x-axis here is the temperature. So our temperature goes up, our revenues go up. This would be an example of a linear line, and it actually starts to go up a little exponentially here at the end. But this would be fairly typical of a business and what a business would look like. So this looks pretty good. If we knew, right, if this was 100, that would mean for every single degree in temperature, we moved up a certain amount in revenue. Let's say $5 for every degree or $1 for every degree. That would be a perfect linear line. But of course, the real world doesn't work that way. It's never going to be perfectly linear. But 57, pretty high number. The other thing we want to look at is our P values on the temperature. It should be really close to 0, and that number is. So we are good there. We want a really low number there. So that's just showing us that we've got a pretty good P value in there. Again, don't get too caught up on all of these stats. If you want to learn more about them, of course, there's plenty of places where you can do that. But for our purposes, it's really not that necessary. Now, the key things here, the coefficients. What this is saying is approximately for every degree in temperature, we're increasing our revenues by $3.17. That's really the number that we want to know. That's a key number. Now, intercept, if you recall, I did not click 0. Let's go back to what this looks like here. Constant is 0. We did not click that. So what that's going to do is, by not clicking this, it's showing me that minus 30, let's say, is the intercept. That's where 0 degrees intercepts at minus $30. Now, we didn't have any 0 degrees on my temperature scale, so that is why we're showing negative revenue. We're not going to have negative revenue on these, but let's just assume that the temperature never got to lower than 10 degrees, because I believe that's how I had it set up. So it really starts at 10 degrees, which makes sense, because at 10 degrees, what did I say? For every 1 degree in temperature, we're increasing our revenues by $3.16. Well, what's the formula? Let's do temperature and revenue. Now we're trying to solve for revenue. So let's put in the lowest temperature that we had. Let's say it just never gets below 10 degrees here. So how would we figure that out? What would our revenues be? Well, we would take the intercept, we'd add that to the temperature, and we're going to put this in parentheses, the temperature multiplied by the coefficient for temperature. So that's going to give us about $1.67 on a 10-degree day in revenue. And now we could just take that same formula and say, at 50 degrees, what can I expect? About $128 in revenue. Okay, 95 degrees, I could expect a $271 day in revenue. Right? So this should make sense. Now, are we going to guarantee that we make $270 in revenue on a 95-degree day? No. There might be other variables that we'd want to look at. Perhaps days of the week we'd want to add into this. So maybe on Mondays we don't make as much as we do on Saturdays. Maybe holidays have a factor. Maybe precipitation. Maybe on days where it's raining, it lowers our revenue. Maybe on days when the sun is shining, it raises it. We can add all of these factors in, and for the more accurate ones that we have, our squared number is going to increase, and it's going to make this number, revenue, what we're trying to predict, a lot more accurate. Okay, so this is a very basic example. This should give you a good basis for what we're looking at now for sports. So let's head on over to a spreadsheet for the NFL and see how we can build a regression model there. All right, guys, let's go to the NFL and let's talk about modeling very basically, doing a very basic linear regression model on the NFL. And I'm going to base this on my power ratings that I post on DFS Army and here at the Sharp app. And you could build a model just simply using this statistic, which is my power rating. Now, if you want to get more advanced, you're going to use and add maybe more statistics to this model. But let's use my ratings for now, which are easily accessible. And again, you could use anyone's ratings that are reputable out there and see just how good they are in relation to predicting. And we could do this with linear regression. So here are my ratings taken from the 2020-2021 season. Tampa was my highest rated team. Believe it or not, New Orleans rated slightly higher than Kansas City, so on and so forth. Jets were the worst team. I then calculate all the scores for the season. So I've done that already for you. Several places online, of course, where you could get this. Within my own power ratings, I have this information already, so it's fairly easy for me to do. I keep track of this, but if you're doing it manually or you're pulling it from a website, these are not difficult numbers to find, of course. And this is every single game from the 2020-2021 season. I make a column for my away teams, their score, the away score, the home team, the home score. And then I want to calculate the scoring margin. Now we're going to do this in the perspective of the away team. You could do it in the home team perspective as well. Does not matter. It's going to work out the same. You'll see as we go. Now what I do is a simple VLOOKUP for the away team to find out what their power ranking is. And then I post that here in column F. And then I want to know what the opponent or the home team, this should say the away power ranking, and this should say home power ranking. So now that we have that, we can do a very easy linear regression model. So let's do just like we did earlier. So let's bring up data and data analysis. We'll go to regression. Let's clean this out because it's got the old ranges in there. And now let's figure out what our Y range is going to be. Well, we want to know what the score margin is going to be, the scoring margin. That's what we're trying to solve for, just like we were trying to solve for how much revenue we were going to make. Well, we want to know what the score is going to be on a future game. So we're going to take this entire column, scoring margin, and that's going to be my Y range. That's my dependent variable. What's my X range? Well, I want to know how does the power rankings affect scoring margin. So I need to know my away power ranking and my home power ranking. Now, unlike before, we're now adding two different variables into the equation, and we'll see how that works. We're going to leave constant is 0 empty again, and let's input this or output this right here on this same spreadsheet and or worksheet, and let's go right here into U1. We click OK. Let's see what happens here when we run this. So we get a 33.3 R squared, so about a 33, which is not terrible for just having really one statistic in our model. Of course, it doesn't work as well as that temperature did, but you see this, there is a line that increases as the x-axis gets higher, as the number gets higher, we can expect scoring margin to increase. That should make sense. So the better teams have a higher power rating, therefore they should win by a larger margin over teams with lower power ratings. That's what this chart is basically telling us. Okay, now we'll look and just make sure we looked at R, and let's make sure our p-values are low, and they are. Now in this instance, the intercept is going to be pretty close because we're looking at away teams versus home teams. This intercept is going to be pretty close to what the home field advantage was last year, which was, I believe, somewhere around 0.6 points. It was very minimal, right? So because of the lack of fans at home events, the home advantages in a lot of sports went down to almost nothing. And that was certainly the case in the NFL, something I talked about last year on a podcast, and the reasons for that. And we'll get into that on another one of these videos. But the intercept here, because we did not use 0, this should be close to what the home field advantage would be. Now, again, it's a negative number because we're doing this in the perspective of the away team. Now, this is saying the away team, for every point of power rating, they can expect to gain 1.36 points or 1.37 points in scoring margin. And conversely, they lose 1.35 points in scoring margin for every increase in the home team's power rating. Okay, so how would we figure out now what the potential margin should be for a team based on these statistics for a team, two teams playing each other? So let's just take Tampa Bay as the away team. We'll say they're away. And let's say the home team is Carolina. What we would do is we would do a VLOOKUP of Tampa Bay, and we go to the power rankings, and we've got those here so we could find out what their power ranking is. We're then going to multiply that by the away team power ranking coefficient. That gives us this number here. We're going to do the same thing for Carolina, which is the home team. So we're going to do a VLOOKUP on Carolina, find out what their power ranking is. This false is just to make sure that we are using the same name, that we don't have a bad name in there or a typo. And again, I have to multiply this by the home team's power ranking coefficient or power rating coefficient. I would then take the difference or add these two up. So if I did the sum of these two, I would then need to add in my intercept, because that's going to be the home field advantage. And what this is saying is Tampa Bay is 11.2 points better on the road than Carolina based on this model. So we could change this, and let's just say we go with Dallas and New Orleans. We would see here Dallas should be getting 13 points. Now, this is based on last year's numbers, of course. Again, we could do the New York Giants and Las Vegas as the home team. And in this instance, Las Vegas should be a 3.5 point favorite over the Giants at home, according to our model. So hopefully this makes some sense to you. Now, another way to look at this would be to get rid of the home and away, which I kind of like here, because I think this gives us more data. Teams actually don't play differently at home and away. The reason for a home field advantage is almost all based on how referees ref the games with a full capacity crowd. They do favor home teams. What we'll do is we'll add our own home field advantage as we know it. And we can make a guess just historically on what home field advantage is for this particular sport. So I already did this here. I just put a little highlight on there so I know that those are the home teams going down. So if you see, this is the first game of the year, Kansas City won by 14. If we look at this, this was the power rating of Kansas City. This was the power rating of Houston. I'm just going to scroll up to our first line. You'll see it's inverted here. All right, and that's all I did was take every single game. I took the home teams here, put them in this column, left the scoring margin as they are. So it just, of course, inverts because now Kansas City had a plus 14 scoring margin. Buffalo was plus 10 against the Jets. New England was plus 10 against Miami, so on and so forth. It's basically just inverting all of these columns to now make this power ranking and opponent power ranking. I keep saying ranking, but it should be rating, right? So this is a rating number. And so now let's figure out just what the power rankings, regardless of being home or away, do. And we'll do this again by running a data analysis regression. And of course, again, what's our y-axis going to be? Well, we're trying to solve for scoring margin. So we're going to want to do all of the scoring margins here. Let's now figure out our X range, which again is going to be the power ranking of, or power rating of ourselves and our opponents. So we take all of that into consideration. The rest of this is going to remain constant. We're not changing anything except for where we want this to be seen. And let's show this over here. We'll show this in AN1. All right, so now here is the difference. So our intercept, which makes sense now, is basically 0 because there is no more home field advantage. We weren't solving for home or away. And these two numbers should be pretty close to even again. So we're going to come up with a slightly different number on our model as far as how much of a favorite each team should be. So let's go back to Tampa Bay and let's say Carolina. And we're going to do the same exact thing. So we're going to do the VLOOKUP of Tampa Bay, and we're going to go back to our power rankings and find the rating for Tampa Bay. We do that with a VLOOKUP, and we're going to multiply that again by the power ranking coefficient. Now we can copy this down, and what that's going to do is just give me the same thing here for Carolina. It's looking up the Carolina. We're doing a VLOOKUP in the power rankings, and we're taking the opponent. This is the opponent in this situation, the opposition team. And now we do let's just say we believe that the home field advantage was a half a point. So we'll put home field advantage of 0.5. And let's say Tampa is the away team, Carolina is the home team. What we simply do here now is figure out what the line should be for Tampa Bay, which would be adding all of these together. And for Tampa Bay, we're going to subtract half a point. They're on the road. We're taking out that half a point, and the line becomes 10.8, or let's call it 11. Tampa Bay would be an 11-point favorite in this model. I kind of like this a little bit better than the previous one, just because we're getting more data here. And there should not be, there's always going to be a difference between away and home, and I just don't believe that a lot of that difference is necessarily related to the fact that the teams are home or away. So now if they were playing in the Super Bowl, let's just do the Super Bowl matchup last year. Obviously it's Tampa Bay and Kansas City. We would take out, or let's just change this to 0 home field advantage. And we would have Tampa should be favored in this game by 2 points. So if they played on neutral site, we would have had Tampa at 2 points. Of course, this is after the Super Bowl, but the numbers didn't change all that drastically. We did like Tampa last year. And if they played on a neutral site after that Super Bowl with the numbers that I had, Tampa should be favored. That should make sense, just strictly based. I know one game doesn't mean everything, but based on how they looked in the Super Bowl, Tampa probably was the better team than Kansas City, as they pretty much dominated that game. So this is a very, very simple way to figure out a model, to do a model. And of course, you can continue to add more statistics. So if there's another statistic that you want to add to this, you're going to want to go through the same thing, check the p-values, see, does that increase my r-squared? Let's say you added some sort of a statistic in here and it increased our r-squared up to 50. Well, that would be very, very solid. and would be certainly something that you'd want to put into your model. If it decreased our square, then it really wasn't something that you might want to use. I think an easy way to look at this is just kind of do this for a bunch of different statistics and then pick the ones that you really like and then put them all together, and you would run the regression model just like we did here and then do the same exact thing. So you're going to be adding in for the team that we're looking for, if it's their specific statistic. That's why it's kind of important to put the headings in there. If it's their specific statistic, like let's say we added in rushing yards per attempt offensively, or we're looking at this from Tampa Bay's standpoint, we'd want to do this as you see here. We multiplied their power ranking. Well, if we had something in here, rushing yards per attempt and opponent rushing yard per attempt, we would do the same multiplication of whatever Tampa's rushing yards per attempt were. We'd have a table somewhere that said Tampa's rushing yard per attempt is X, and then you would have some sort of a coefficient like we do here that we would multiply that by, and then that would get put into this number. Same thing with my opponent or Tampa's opponent. We would have, in this case, their opponent's power rating coefficient, and then we would have opponent's rushing yards per attempt given up or defensive rushing yards per attempt as a coefficient here. So you would multiply that by their actual rushing yards per attempt given up. So in this case, Kansas City, let's say they give up 4.5 yards per attempt, and we find out that the coefficient is 0.25. So for every 1 yard of rushing yards per attempt, it would be worth 0.25 on the scoring margin or spread. So hopefully that makes a bit of sense to you. What we're really doing here is just compiling as many statistics as we can that are going to have some sort of a bearing and change this R squared and really flatten this line out as much as we possibly can. The more linear this becomes, the more predictable the outcome is going to be. So our X, which is our dependent variable, what we're looking for is points and scoring margin. So we're trying to find the scoring margin between two teams. We're adding in home field advantage to that, and we're going to hopefully flatten out this line. So what you really want to do is start playing with this, come up with your own statistics, and just have a little bit of fun. If you like messing with numbers and statistics and building your own model, doing this can be a lot of fun. And if you come across something that really works well, it can be profitable. All right, hopefully you guys have a better idea now of what a linear regression model looks like. This is very basic. Of course, the examples I showed you are not necessarily going to make you any money, but it's a good starting point. You can use other people's power ratings, not just mine, of course. You could try to combine them and just mix and match, see how it works. There's a Sagan rating out there. There's all sorts of ratings that you can find on the internet and see how their model would work if you added it to a linear regression. Then I would just mess around with some statistics, depending on the sport. We're talking NFL here. Look at what you think is very important to add into the equation. I'll let you know that my power ratings are strictly based on yardage and score. That is it. So if you're adding more types of yardage numbers, rushing, passing, it may not change the model if you're doing a linear regression all that much, but adding things like perhaps turnovers or penalties or special teams, anything like that that you might want to try to add in to the equation may also help and increase the R squared, which is going to help be more predictable on your model. Of course, you're going to want to back test these models, do a lot of testing, but I think the exercise is really good. And for those of you who are new to modeling, this is a great way to learn how to model for yourself. And I don't think it's terribly difficult to do as long as you have Excel or Google Sheets, something like that, and you have the time and you want to mess around with this sort of stuff. So use a lot of the statistics that are out there, and then maybe you get creative. The way people become really good at this are inventing new statistics. Not saying you might be that person who's going to invent new statistic, but quite possibly. I mess around with different statistics all the time looking for something that's going to give me an edge. Perhaps there's something that you're not seeing out there that you think needs to be a statistic. Perhaps combining a few statistics. whatever it may be. Have some fun. There's the art to this and the science. I showed you really the science. You have to be the artist. You need to come up with the creative ways to implement the tools, right? So a sculptor is going to have a chisel and a mallet and whatever tools, if they're using a saw to sculpt out of wood, whatever it may be, the tools that they use, that's more the science. But the art is their interpretation, how they use those tools to create whatever type of artistic piece they are going to create. So that's why when I look at modeling and sports betting, there's a lot of science, there's math. 2 + 2 = 4. It always will. So we're going to use our basic math skills and maybe some more advanced math skills and then try and be creative. I always think mathematicians and physicists and chemists, they don't get the credit for necessarily being creative people because they seem to be more analytical and they're doing things scientifically by the numbers. But the ones who are great at it are creative, because you need to be creative to think outside of the box, think where other people have not thought before, but you need to do that while using the tools that are available to us. So hopefully this helps you guys and you'll start playing with this. Please send me feedback if you find something that is working really well and you want me to take a look at it. We'd love to analyze anything that you come up with and see if we can improve it, help you with it, comment, critique, whatever it may be. If you have questions, you know I'm always available over in our Discord channel, which if you guys are not a part of, you really should be. Sign up for Discord. Here in the Sharp app, we have links to the Discord, and you should be taking advantage of that for not only the Sharp Academy, but to speak to the coaches, find out how they're modeling, what they like on a day-to-day basis, and just meet some of your fellow sports handicappers who are all trying to learn and become sharper. That's the point of the Sharp app. So until the next lesson, good luck to you guys. Hopefully you can use this to make some money.